It takes less than a minute to bring down a tree, just a few hours to turn it into lumber, and almost nothing goes to waste. But what happens after the tree hits the ground? Today, join RaWMachines as we follow the journey of timber, from snow-covered forests in the United States to modern sawmills, where it's transformed into high-quality lumber. Let's get started. Winter arrives, and the entire forest seems to fall asleep. The ground freezes. The sap inside the trees stops flowing. All life falls temporarily silent. Yet, it is at this very moment that the journey of a log truly begins. From the midst of the snow, the Ponce harvester moves into position. Equipped with a fully computerized cutting head, it can embrace a tree trunk, fell it, strip the branches clean, and buck it into multiple logs, all in less than a minute. Finally, the automated computer system cuts the trunk into individual segments with lengths calculated precise to the centimeter. But this is only the beginning. The logs now lie scattered across the forest floor, far away from where they will be processed. How do you haul hundreds of tons of timber off steep terrain without building new roads? The answer lies in the air. A system of steel cables is stretched taut between the mountainside and the staging yard at the foot of the hill. One by one, bundles of logs are hooked to the carriage, slowly lifting off the ground. Suspended in midair, the tree trunks cross ravines, glide over small streams and dense forest, all without requiring a single new road. From above, the entire system looks like a forest cable car, but instead of carrying people, it is transporting pieces of an entire woodland down into the valley. The final destination of this journey is a staging yard right at the edge of the lake. Hundreds of logs are gradually stacked into massive piles, waiting for the next leg of their journey. For centuries, before modern roads existed, rivers and lakes served as the most vital transport routes for the logging industry. Today, in regions with vast networks of natural lakes, the water remains an efficient choice for moving massive volumes of timber. A loader gets to work. Its hydraulic grapple effortlessly lifts bundles of logs from the staging yard, neatly arranging them into the barge's hold. With each grab, several tons of wood are set down with near absolute precision. Once the cargo hold is full, the barge slowly departs from the dock. No loud horns, no long convoys of trucks. just ripples spreading far behind its bow. After hours of travel, it docks at the mill's receiving bay, and what happens next makes almost anyone seeing it for the first time think something has gone wrong. Instead of using a crane to unload the logs one by one, the entire barge begins to tilt to the side. Within seconds, hundreds of tons of timber slide off the deck all at once and plunge straight into the water. This is no accident. It's actually the fastest way to unload cargo. Using a crane to unload each individual log could take hours, but with this self-unloading barge mechanism, the entire load is dumped into the water in just a few minutes. After being released into the water, the logs continue their journey in a very unusual way. A log boom moves into position. Using a system of cables and guide floats, it gathers thousands of floating logs into large bundles and slowly tows them toward the mill's log pond. Transporting the logs by water allows massive quantities of timber to be moved efficiently while preserving the wood's natural moisture before processing. This is the final stop before the logs enter the production line.
Oh, fuck yeah.
In just a few hours, they will be lifted out of the water and pass through debarking machines, laser scanning systems, and high-speed saw lines. By the end of the process, they will be transformed into lumber, used in construction projects around the world. An American sawmill is like a living mechanical organism, breathing through steam, moving with electricity, and thinking with data. Every day, thousands of tons of logs enter the system, and just a few hours later, they are transformed into perfectly milled, uniform lumber with exceptional precision. As soon as it hits the conveyor belt, each log passes through a Meditech scanning system. A series of lasers and X-rays quickly scan through the timber, building a full 3D model in just seconds. Going far beyond surface appearance, the system detects dead knots, grain deviations, moisture levels, cracks, and internal defects that are completely invisible to the naked eye. All the data is then sent to a computer to calculate the optimal cutting pattern. The goal isn't just to yield the highest volume, but to generate maximum yield value with minimal waste. Deciding how to cut used to rely entirely on a sawyer's years of experience. Today, Meditech technology has digitized that entire process. What once took decades of expertise is now completed in an instant, with far higher accuracy and consistency. Following the analysis, the system automatically sorts each log by size, species, and intended use. The conveyors then direct the raw materials to the correct processing line without any manual intervention. Thanks to this high level of automation, the entire mill can operate continuously 24/7, with steady throughput and uniform precision. This technology serves as the backbone of the modern timber industry, ensuring maximum value is extracted from every single log before it moves on to the next stage of processing. Now, follow me to the green tree plant, where the processing journey takes its next step. The first stage is debarking, a process that seems simple enough on the surface, but carries a rich history of human innovation. In the early days, first-generation debarkers relied on large, grinding wheels fitted with steel knives. While they stripped away the bark, they also gouged into the good wood underneath, eroding the raw material's value. breakthrough came in 1946 when John Mellett developed the hydraulic ring debarker, which could contour to the natural shape of each individual log. This design quickly became the blueprint for many of today's modern machines. Here at Green Tree, the 48-inch Mellett LMR operates on that exact same principle. High-speed rotating scraping blades shave off only the thin outer layer of bark, leaving the inner wood virtually untouched. As a result, every log retains its maximum value before heading into the sawmill line. At Green Tree, there is no such thing as waste, only raw materials waiting to take on a new form. Right after debarking, a vibrating conveyor system collects all the bark, wood chips, and sawdust. Operating on the principles of mass and inertia, the system vibrates at frequencies between 900 and 1,200 cycles per minute, sorting materials with up to 95% accuracy. Every byproduct is put to good use. Bark becomes biomass fuel to heat the drying kilns, while wood chips and sawdust serve as raw materials for paper, plywood, engineered wood, and energy pellets. As a result, Green Tree utilizes nearly every single part of the tree. Even what seems useless is funneled back into the production cycle, minimizing raw material waste and driving up operational efficiency across the plant. Once cleaned, the logs pass through a WDH-120 infeed chute as they prepare to enter the main sawing area. Sensors measure the diameter and length of each log, while a hydraulic mechanism automatically grips and aligns it. This ensures every log enters the saw at the exact predetermined angle. This is the core area, where the most critical step takes place, dissecting the log. At the heart of this station is a carriage system and a massive steel band saw blade running continuously over heavy flywheels. Unlike traditional circular saws, the bandsaw features a thinner blade that creates a narrower kerf. This reduces the amount of wood turned into sawdust and boosts the overall material recovery rate, a vital factor driving the efficiency of the entire production line. The process unfolds like a dance of steel and timber. The carriage feeds the log into the blade, a rough board is sliced off, the carriage retracts, the log rotates, and the cycle repeats until a solid squared timber block takes shape. Yet, the soul of this entire process lies not in the machinery, but in the operator. Seated in the control cabin with a joystick in hand, they no longer rely on physical strength, but on a sharp intuition honed through at least 6 months of rigorous training. The operator must read the shape and understand the grain's microscopic structure, deciding on a cut direction that minimizes cracking while maximizing the value of every single board. Following the main cut, The boards pass through a resaw for further breakdown, an edger to strip away rough sides, and a trimmer to remove unwanted knots or cracks. Every split-second choice made by the operator is a seamless fusion of precise digital data and master craftsmanship. At Green Tree, they believe that while machines deliver absolute precision, only humans can bring artistic value and true respect to every gift of nature. Leaving the sawing area, the boards head into an automated inspection system. Laser sensors scan continuously to detect color flaws, surface unevenness, or micro cracks as tiny as 0.5 millimeters. Boards that meet the highest standards move on to the sanding stage to achieve a smooth, uniform surface. Meanwhile, all sawdust, wood chips, and scrap generated during processing are fully recovered for reuse, leaving virtually no material wasted. Finally, the finished products are bundled, labeled, and tagged with a traceability code. With a quick scan, manufacturers can trace exactly where the tree was harvested, when it was processed, and every step it took before leaving the mill. A tree that once stood in the forest now carries its own technical profile, a testament to its complete journey from natural living giant to precision-crafted wood. Leaving the United States behind, our journey takes us to southern Germany, where sprawling fir forests have sustained the woodworking industry for centuries. Nestled in this serene landscape lies Sägewerk Deal. While American mills impress with their sheer scale and speed, this facility pursues precision in every single detail. It embodies the true German mindset. It's not about producing faster, it's about producing better. That philosophy is built by the people themselves. To become a master craftsman, many technicians at Deal undergo up to 7 years of training. They don't just learn how to operate machinery, they study the structure of different wood species, the characteristics of the grain, and how to spot subtle anomalies during processing. It is this deep foundation of knowledge and experience that enables the mill to maintain exceptionally high material recovery rates, while upholding the reputation for quality that the German woodworking industry has built over decades. Like most modern sawmills, the first step at deal is debarking. The logs pass through a debarker, where rotating blades travel around the tree trunk to strip away the outer bark with virtually no damage to the soundwood underneath. Thoroughly removing the bark not only protects the saw blades in downstream operations, but also keeps dirt, rocks, fungi, and insects from entering the production line. What truly sets deal apart is its saw blades, crafted from stellite alloy, a durable blend of cobalt, chromium, and vanadium. To the master craftsman at Deal, these blades are nothing short of true warriors. They withstand intense frictional heat, hold an edge far longer than standard steel, and are virtually immune to snapping during operation. Powered by a 55 kilowatt motor, the log is precisely positioned by hydraulic clamps and laser guides before entering the cut zone. As the blade engages, hold-down rollers grip the log firmly to minimize vibration, producing smooth, remarkably stable cuts. The spacing between the blades is adjusted according to the required product dimensions, while horizontal blades simultaneously trim off the rough edges. As a result, the finished output consistently achieves high flatness, tight tolerances, and a uniform surface finish. Leaving the main sawing station, the boards head into the trimming line for final finishing. Before cutting, a laser system remeasures the exact dimensions of each board, allowing the analysis software to determine the most efficient cut plan. The machine then automatically trims off cracked ends, adjusts the width, and brings the product strictly up to technical specifications. After sorting, the boards are stacked into bundles with wooden spacers to allow uniform airflow before heading into the drying kilns. Rather than blasting the timber with extreme heat in a short window, DL employs a fully computerized drying process. Temperature and humidity are gradually adjusted stage by stage, while sensors continuously monitor the moisture content deep within the wood's core. This process can take several weeks, but in return, the wood dries evenly, minimizes cracking and warping, and perfectly preserves its natural color and grain pattern. Finally, the finished boards are assembled into bundles, securely strapped with steel or heavy-duty plastic banding, and wrapped in protective covers to ensure safety during transit. Bundle by bundle, the timber is loaded onto train cars and trucks, setting off on a new journey, leaving Germany behind to help build structures and homes around the globe. And so, we've reached the end of a long journey, tracing the path of a tree from the vast forests of America to finished lumber, ready to take its place in homes, bridges, and construction projects around the world. From freezing winter mornings when the forest was still blanketed in cold, we witnessed modern harvesting machinery fell, delimb, and cut trees to length in less than a minute. Then came Skyline cable systems traversing mountain slopes, barges quietly crossing lakes, and log booms transporting thousands of logs to the mill, all while barely disrupting the forest's natural rhythm. Once the mill gates opened, an entirely different journey began. Lasers, X-ray scanners, and artificial intelligence analyzed every single log before the first saw blade even made contact. Debarking, sawing, sorting, drying, and finishing lines operated continuously with near-absolute precision, transforming rough logs into high-value products in just a matter of hours. Yet, what impresses us most isn't the sheer scale of the machines or the speed of the production lines. What's truly admirable is how human expertise, accumulated over generations, has been paired with the latest breakthroughs in science and technology to maximize the value of every single log. Here, almost nothing goes to waste. The trunk becomes construction timber and furniture. The bark is used as biomass fuel. Wood chips and sawdust are processed into paper, engineered wood, or energy pellets. Every part of the tree is given a new life, creating a more efficient and sustainable production cycle. Perhaps that is the greatest message the modern timber industry has to offer. The value of technology lies not just in building faster or more powerful machines, but in the ability to use natural resources intelligently, accurately, and responsibly. When every cut is optimized just a little more, and every board is utilized just a bit better, millions of trees across the globe will be used far more efficiently in the years to come. Thank you for joining RaWMachines on today's exploration. We hope that after this episode, whenever you see a piece of lumber or a newly built home, you'll remember that behind it lies a decades-long journey of nature, along with thousands of hours of labor from countless people and modern machinery. If you love manufacturing processes, massive machinery, and the fascinating stories behind industries around the world, don't forget to subscribe to the channel so you never miss an upcoming episode. Thank you, and see you next time.